In this video, we're going to be looking at word problems that will result in what's called rational equations. Now, we studied rational equations earlier in the semester, and those are equations that lead to fractional expressions, and we're going to get rid of those fractions by multiplying by the LCD. But before we get to that, let's go over some vocabulary. We're going to see things like consecutive integers. Now, those are numbers that are in a row. 1, 2, 3, -2, -3, -4. There's no decimals or fractions. But we have to read the problems very carefully. If you're asked to find two consecutive integers, you always let the first one be x and then the next one x plus 1. Because if we take some consecutive numbers, hopefully you can see that you have to add 1 to get to the next one. Now odd, that's the one that confuses most students. If we have 5, 7, and 9, if the first one is x, think about it, yes, you have to add 2 to get to the next odd number. Even, same thing, it's still plus 2. 4, 6, 8. Again, if this first one is x, and we'd add 2 to get to the next one. So even and odd, I know that's confusing, they're set up the same way because they're spaced evenly every 2 on the number line. But the first example we're going to be looking at involves reciprocals. Now you know what that is. If the number is x or x over 1, then its reciprocal is going to be 1 over x. So let's look at this first problem. It says the sum of a number and its reciprocal is 29/10. What is the number? Well, reading the directions, it says I need to define my variable. So that means I need to say, what does x stand for? Well, pretty easy. X is going to be the number that I'm looking for. And that's all I need to find. Now, what do I need to do with that? I need to, the sum means to add the number, so I have x plus and its reciprocal. It is x, so its reciprocal is 1 over x. And is means equals 29/10. So you can see this is a rational equation because we have these fractional expressions. I'm going to put that over 1. So we need to find the LCD, which is one of every kind of factor in the denominator, which is 10x. And so I'm going to multiply every term by 10x over 1 to get rid of those fractions. Now here nothing cancels because we have 1's on the bottom, so we're going to multiply and get 10x squared. Here the x's cancel and we get 10. The 10's cancel. Don't leave out that x. That's 29x. Now most of these are going to lead to quadratic equations, which we're probably going to have to factor to solve. And sure enough, this is quadratic, so I'm going to move this to the other side. That becomes negative and set it equal to 0. And then I hope that does factor. So let's try it out. I'm going to try 5x and 2x, and I'm going to try 5 and 2 again, but remember I can't put the 5 with the 5, so I'm going to try it this way. So let's see, that's going to be 4x, and that is 25x, and if they're both negative, I get 29x, and I get that positive 10. Now after you factor, you want to set each factor equal to 0 and solve. So we have 5x is equal to 2 and x is 2/5. Or we have 2x equals to positive 5 and x is 5/2. Notice they are reciprocals of each other. And it says what is the number? Well, we can have two answers. We can have 2/5 or 5/2. And if you wanted to check that out, you could add 2/5 plus 5/2 and see if you get 29/10. And you will. Now the second example might require a little bit more work. Right? It says the difference, that means to subtract, the difference of the reciprocals of two consecutive integers is. Alright, so we can get to the equals half, that's the easy part. Two consecutive integers. Doesn't say odd, doesn't say even. So I want to say the first integer is x, and so the next one would just be x plus 1. But it doesn't say just to subtract these consecutive integers, it says to subtract their reciprocals. So I'm going to have 1 over x minus 1 over x plus 1, and that's going to equal to 1/2. Now notice I've spaced that out because I know I'm going to have to multiply by that LCD, which remember is all those factors. So I'm going to have x, x plus 1, oops, and the 2. I'm just going to stick that in front. Remember, those are all over 1, so we can reduce out all those fractional expressions. So the x's cancel, so I have 2 times x plus 1. Here those cancels, don't leave out that minus, so I have 2x. And here the x's cancel, oh, no, just the 2's, and I have that x times x plus 1. Now I'm going to get rid of the parentheses. Don't forget to distribute all the way. I'm going to collect like terms, and notice the 2x's add to 0. So again, I have a quadratic. So I'm going to move this positive 2 to the other side, and it becomes a negative 2. So one more time, I'm going to factor. I think that's going to be pretty easy here because I know 2 times 1 is 2. I need to make that positive and that negative to get that positive 1 in the middle. So I have x plus 2 is equal to 0, and x minus 1 is equal to 0. So x is negative 2, or x is positive 1. Now here, this is why I want you to do this. It says, what are the integers, both of them? So I found x. What I need also is the second one, which would be x plus 1. So I'm not done yet, all right? So I need x plus 1. So just take this negative 2 and plug it in for x. So negative 2 plus 1 is negative 1. Same thing here. 1 plus 1 is 2. So I have negative 2 and negative 1. I also have, I guess I should write the word and. I also have positive 1 and positive 2. So I have 2 sets of answers. So the key thing here is those reciprocals and 2 consecutive integers, the x and x plus 1. Now this one is very similar to what we just got through doing. Let's look at the different words. We have sum, which means add. We've got those reciprocals, but this time we have that extra word of even. And of course we know is equal. Right, so we need 2 consecutive even integers. Well, the first one's still going to be x, but the second one is going to be x plus 2. Even if it had said odd, we were going to do x and x plus 2. We're going to set it up just like we did on problem 2. We've got to take those reciprocals. But this time we're going to add, and it's going to equal 9/40. Right, so I need to have my LCD, which is all three of these, 40x and x plus 2. All right, and now I'm going to reduce. And that's 9x times x plus 2. Let's write it like that so we won't leave out some terms. Now I need to distribute. And again, make sure that 9x gets to the 2. So that's 18x. Ooh, this time things don't cancel out. But let's go ahead and collect like terms. That's 80x plus 80. I know you're thinking those are really big numbers. Just hold on. It's not going to be so bad. Let's subtract 80x from both sides and subtract 80. And again, I have a quadratic, so I need that all-important 0. So this is going to be, I believe, negative 62x. Now we have a quadratic that we need to factor. And those are some really big numbers. I don't see that I could factor out a GCF, so I'm just going to dive in. And because these numbers are kind of big, instead of trying my regular 3 times 3, I'm going to try 9x times 1x. And then 80, the first thing that comes to my mind is 8 times 10. So I know that 9 times 8 is 72, so that's kind of close, and so if I put the 10 there, what's going to happen? I'm going to have 10x, and I'm going to have 72x, and if I make that negative and that positive, I think everything works out. All right, so I'm going to set each factor equal to 0, and I'm going to solve for x. And then I'm going to go back and make sure I look at my problem. What am I supposed to find? I'm supposed to find consecutive integers. Well, as you recall, at the top of your notes, integers are whole numbers, positive and negative. They do not include fractions. So as I look at my answers here, can I have negative 10/9? No, because this is not an integer. Not because it's negative, but because it's a fraction. Am I done here? No, because I don't just need x, I also need that x plus 2. Remember, 2 consecutive even integers. So what's 8 plus 2? It's 10. So my answers are 8 and 10. Let's look at the second type of word problems. They're going to involve people or machines working together. Probably some of the easiest word problems you're ever going to do, as long as you kind of know this setup. 1 over someone's time alone plus 1 over the time alone equals 1 over time together. That's your setup. Now the 1 comes from the one job that they're trying to achieve. So let's look at number 4. Paris can wash her car in 4.5 hours. So time alone is 4.5, but let's change that to an improper fraction, which would be 9 over 2. Celia, she can wash the car in 7 hours. Working together, we don't know, so we're going to put that as x. That's going to become x. Those are numbers. So let's see what we have. We have 1 over 9/2 plus 1 over 7 equals 1 over x. Now let's talk about that. That's pretty ugly. What does that really mean? That means 1 divided by 9 over 2, which means 1 times 2 over 9, which is just 2/9. So I'm going to replace this with that and rewrite this equation. So I have 2 over 9 plus 1 over 7 equals 1 over x. So how do we solve for x? Well, we're going to find that LCD. So we need 9 times 7 times x. I believe that's 63x. So let's multiply everything by 63x and reduce. So 9 goes into 63 7 times. Don't lose that x. So I have 14x plus 9x equals just 63. And look at there, not a quadratic. Just collect like terms. I believe that is 23x equals 63. So it looks kind of ugly, but that's okay. We're going to divide by 23, and x is 63 over 23, which you could not reduce. You can leave it like that. Now remember, we wanted to know Paris can do it in 4.5 hours, Celia 7. So your answer should be less than those, because if you work together, it should be less time. And if you notice, 2 times 23 is 46. So 23 goes into 63 2 times with some left over. And so that means it's a little bit more than 2 hours. But again, you don't need to worry about that. This would be sufficient. Let's look at the last example. It says, working together, Joseph and Dylan can write the computer program in 11 hours. So that's together time. Working alone, Joseph can write the computer program in 15 hours. So we have Joseph 15 hours. How long does it take Dylan to write the program by himself? right? So remember, 1 over time alone plus 1 over time alone equals 1 over time together. That's our formula. So we have 1 over 15 plus 1 over x, those are alone times, equals 1 over 11. So again, we find that LCD, which I believe is 15 times 11 times x. So it's 165x. So again, reducing, I know 15 goes in there 11 times, so I have 11x. Here the x is reduced, and I have that 165, and 11 goes in here 15 times. No quadratics, just basic solving for x, so let's subtract 11x from both sides and divide by 4. And I get x equals, let's go ahead and write that as 41 1/4 hours. Now that's a long time. I realize it's an ugly answer. I just made up the problem. So Dylan working alone, if I did that correctly, would be 41 1/4 hours. A long time.